Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. In this video I will do a demonstration on how to configure OSPFv2 in a single area. This is packet tracer activity 8.2.2.7, which is part of CCNA semester 2. Okay, so if I just go and grab my packet tracer source files and what we're going to do is 8227. Yep. Okay, now the packet tracer has loaded. This is my topology, so I'm just going to move it to the right here, and this is the activity instructions. So objectives for this activity is to configure an OSPFv2 routing and verify the configuration. Here's our addressing, so we need to have a look later on. A little background information is, in this activity the IP address is already configured, so we are responsible for configuring the three router topology with basic single area OSPF and then verify the connectivity between end devices. So part 1 is configure OSPF version 2. Step 1, configure OSPF on R1, R2 and R3. Use the following requirements to configure OSPF routing on all three routers. So we need to set process ID 10, router ID for each router. Router 1 is going to be 1.1.1.1, router 2 2.2.2.2, router 3 3.3.3.3, network address for each interface, and LAN interfaces they should be set to a passive. We do not use a default keyword. Okay, great, so we have some information there. So I'll go to router 1, go to CLI on router 1, just maximize it a little bit. Okay, so enable, configure terminal, Okay, now it says process ID of 10, so router OSPF 10. Now this process ID 10 is only locally significant only, so it doesn't have to match with any other router. So it's not like EIGRP which you have to match. This has to be the same. Here, because it's a local significant only, it doesn't have to match. This is like a process ID. So process ID of 10. And router ID for each router. So router 1, so router ID for router 1 is 1.1.1.1. Now router ID is represented in like a IPv4 format, like this 1.1.1.1, but it's just a number. It's just like identification for this router. This you could potentially put it 255.255.255.255. Again, it doesn't really matter what number you put. That's just like identification number. So it's got nothing to do with any IP address that you have on the router. Now, the important thing is, for the two routers to become neighbors, this router ID has to be unique. If it's not unique, if in network you have two routers with same router ID, it could potentially cause some troubleshooting issues. Okay, so router ID 1.1.1.1 for once. Then network address for each interface. So we have to go to see what router 1 is connected to. It's connected to 172.16.1.1. Let me just move a little bit so we can see it better, and the subnet mask as well. Okay, the subnet mask is 255.255.255.0, because it's important on OSPF to know the subnet mask, because we're going to use the wildcard mask from the subnet mask. So if I have a look, like for example, this is from previous videos. So if the subnet mask is 255.255.255.0, then to derive to the wildcard mask, all I need to go on the top put 255.255.255, and then I minus my subnet mask, which is going to end up being 0.0.0.255. 255 minus 255, 0. 255 minus 255 here, 0. 255 minus 255, 0. And 255 minus 0 is 255. Okay, so need to advertise this network. Now, I have to say network 172.16.1.0, that's the network, And the wildcard mask is, as we found, is 0.0.0.255. And then we have to tell what area is it. Since we are configuring a single area OSPF, now first area is going to be area 0. That is known as backbone area. So it's going to be area 0. Okay, excellent. Now there's two ways to configure. You can configure it like this for the whole network, or you can just configure for the single interface, which I really tell my student to do that anyway, because it's more, you are more in control. So for example, instead of doing like this, I would have put the IP address 172.16.1.1 and then 4 zeros, and area, then the area you choose. That's the same thing you're doing. You're advertising on that interface, but instead of enabling for the whole network, you are just enabling for the single interface. Okay, but in this example, it's not asking us to do that way, so stick with what they ask. Excellent. Okay, we have to configure this interface as well. So network 172.16.3.0, this network 172.16.3.1, which is 0 the network. The first value is 1, the second value is 2, because it's 252, so the last address is .3. So the wildcard mask for that is going to be 0.0.0.3. How do I know that? So if I go there and have a look, what is the subnet mask? Subnet mask is 255, 255, 255, 252. We are talking about this one here. Now, if I put all 255s in the top and then minus my subnet mask, then that's going to equal to 0.0.0.3, yeah? 255 minus 252 is 3. The rest is all zeros. Okay, so if I might minimize this and go network 172.16.3.0, 0.0.0.3. And again, tell what area is it. Area 0. Enter. And we have to do it for this network. This network 192.168.10.5, and this is the subnet mask 252. Now, since the subnet mask is 252 and it's a 5 IP address, I know this is going to be .4 is the network ID. So network 192.168.10.4 to wildcard mask 0.0.3 area 0. Okay, so how did I know that that's 4? Right? Let's have a look at this way. So copy that, and the subnet mask is 255, 255.255.255.252. Right? Now 252, if I just write it down in the binary, so 1, 2, 3, 4, 5, 6, 7, 8, copy this. That's 24. 25, 26, 27, 28, 29, 30, 1, 2, 32. So 252, this is the represented in binary. Now I know this digit is 4, right? So I know my increments are going to be in 4. So since this digit represents 4 and is located on the 4th octet, I know my increments that are going to be with 4. So I'm going to start with 192.168.10.0. That's the first network. Then I'm going to keep incrementing by 4. So 192.168.10.4. The next one will be 192.168.10.8. The next one, I'm just going to keep incrementing here by 4, yeah? So that's why, because this 5, it's in between here, between 4 and 8, and it belongs on this network, right? So 192.168.10.4. That's why I put it there. Okay, now, we have advertised, let's go back to the topology. We have advertised 172.16.1.0, which is this network, it's LAN. We advertised 172.16.3.0, which is our interface or network between router 1 and router 2. And 192.168.10.4, which is the network between router 1 and router 3. But we have potential neighbors between router 2 and router 3 on these interfaces, but we will never have a neighbor here on this interface because it's LAN. There's never going to be a router on that way. So we have to passive that interface. And it said the passive interface default is not allowed. Yeah? So the default keyword do not use it, right? So passive interface G00. Since that interface is on G00, that's our LAN. Okay, excellent. If we do show IP OSPF neighbor, there's still no neighbors. The reason why there's no neighbors is because we have not configured the other routers. Okay, let's go back here, and yeah, let's do the other routers. So we go to router 2 now, move it to the right, expand a little bit, CLI, first enable from the user to privilege mode, config T to go to the global configuration mode, and in here we type router OSPF, and it says 10, but we could put any number we want. But if we put 20, it's not going to mark us correctly here, so we have to stick with 10. But it's all I'm trying to say to you that it's locally significant. You can put any number you want there. 10. Router ID we said is 2.2.2.2. Then we have to advertise our local network, so network 172.16.2.0, and this is /24 subnet mask. So since it's /24, the wildcard mask is going to be 0.0.0.255, and this is in area 0. Then we're going to advertise this network, the network that is connected with router 1. So network, what is it, 172.16.3.0, and the wildcard mask 0.0.0.3, area 0. And then we're going to advertise the network that we are connected with router 3. So network. Oh, we already got a neighbor with router 2, you see, with router 1. So we already have a new adjacency, process 10. So process ID 10, neighbor 1.1.1.1 on serial 000 from loading from the memory into full. Loading is done. Okay, so let's type the neighbor, this one. Network here. Network 192.168.10.8, right? And the wildcard mask 0003, area 0. We want to do passive interface the G00 because there's no update going that way. So passive. Oh, let me write down passive interface G00. Done. Copy, run to start. And we're going to do the same configuration, well, similar configuration for router 3. So if I open router 3, okay, CLI, enable, config T, router OSPF 10, router ID, it's going to be 3333, and we're going to advertise the 3 networks that we have. Let's start with this, with the LAN. So network 192.168.1.0, and the wildcard mask is 0.0.0.255 and the area 0. Then we're going to advertise the 2 networks, one connecting towards router 1 and the other one connecting towards router 2. So network 192.168.10.4, and the wildcard 0003, area 0. And the other network 10.8, so network 192.168. You see, there we go, another neighbor now with router 1. I just typed that was with router 1. And you see, as I was typing here, network 192.1, then the message came, and then 68 is down here, dot. This is not very good. I don't like this. So to fix this, right, you have to go to the line console 0, login with 2 G's, sync. So that doesn't annoy you anymore. Okay, so just side note, router OSPF 10, right? Can I have 11 now? Well, yeah. Doesn't make it. You can have as many processes as this router is capable of. So make sure if you are configuring process 10, you are configuring commands on process 10. Process 11, they will start another process. Let me just remove that process. Router OSPF 10, and what was it? Network 192.168.10, and the network is .8. Okay, what is it here? 8, and the wildcard mask is 3, area 0. End. Copy, running config to startup config. Okay. Right away, as soon as I pressed end, as soon as I press enter, pretty much we got a new neighbor there. Okay, so if I go to router 1 and say, see, I've got 2 neighbors, 222 and 333. Right. Now I have to go, I forgot in router 3, I have to disable, that's what I'm saying in Y97, I have to disable the passive interface, my G00. So config T, router OSPF 10, passive interface G00, and right. Okay, you can see now it's 100 on 100. Great, excellent. So if I go to router 1 now and show IP OSPF neighbors, show IP OSPF neighbor. Okay, let me just expand it even more so I can see, we can see it nicely. Move. Okay, so I've got neighbor with ID 2222. Its priority is 0 because it's point to point. Full state is full, and we have a dash there. The dash is because there's no DR or BDR being elected. The reason why we don't need DR or BDR is because it's point to point link. And dead time is 30. So every 10 seconds you're gonna hear hello. Now the dead time is 4 times hello. So if the hello is every 10 seconds, the dead time is 40 seconds. So you should never see this less than 30. So if I repeat the command again, it's just gonna be something between 40 and 30. We never less than 30. If it's less than 30, then there's a problem. The address where we're hearing that hello is 172.16.3.2, and on from 172.16.3.2, and in interface that we're hearing this hellos is serial 000. Okay, and then I got another neighbor, same towards router 3. Show IP protocols. Show IP protocols. We can see that our router ID is 1111. We don't have any filtered list for incoming or outgoing updates. Number of areas this router is only 1, area 0. Is a normal area, so it's not stop or NSSA or anything. That's more CCNA learning for you. Routing for the networks CCNP, I should say. Routing for the networks 172.16.1.0, so that's our network, and 3.0 and 10.4. Passive interface, you can see here, is G00. Routing information sources. Gateway is like we have the neighbors. We have ourselves here as a neighbor, which is ourselves in the topology. 2.2.2, both, and 3.3.3. All administrative distance is 110. Sorry. Okay, we can do show IP OSPF database as well. Now we can see. Let me just clear some screen here. So we can see our database. So we can have router link states. We have type 1 LSAs. Everybody is sending type 1 LSAs, and this is how long the LSA it's been in our database. By default, this LSA will be there for 60 minutes, but every 30 minutes they're going to be refresh. LSA's refresh, and this is how many links each network or each router is sending to us. 5 links. Okay, what is the next task here? Next task is verify OSPF routing is operational on each router. The routing table should have a route to every network in the topology. Okay, so show IP route. So we can see that we have few OSPF routes and connected, directly connected, but let's just see the OSPF routes. Show IP route OSPF. Right. So we have 172.16.2.0 network. Okay, so if I go on the top there, 172.16.2.0. So we have we run this command in router 1. So we learned router 2 LAN interface through OSPF, and 192.168.1.0, that's router 3 LAN interface, and 192.168.10.8, that's the serial interface between router 2 and router 3. Okay, we can ping everything, so make sure that there is a connectivity. So open PC1, desktop, command prompt, I'll put it on this side. PC2, desktop, command prompt, put it on this side. And then I'll do open PC3 as well, desktop, command prompt, put it here in the corner. Okay, minimize this. IP config on PC1, address 172.16.1.2, PC2 IP config 172.16.2.2, and PC3 IP config 172.16.1.2. Sorry, I was thinking like again 192.168.1.2. Okay, so if PC1 can ping PC2 and PC3, successful network configuration. So ping 172.16.2.2. So we ping in this address. Okay, we're gonna lose some packets because ARP resolution. So we resolve in IP address and MAC address, and there we go. Let's try another one. 192.168.1.2. So ping 192.168.1.2 again. And yes, we have a connectivity. So PC2 can PC2 ping PC3. So ping 192.168.1.2. And yes, we have a connectivity. Okay, this has been Astrid Krasniqi showing you how to configure OSPF on a single area network. OSPF, sorry, this is not version 3, this is version 2. Yeah, configuring OSPF version 2 in a single area network. I'll see you in the next videos. Thank you for watching my video, and bye bye.